A locked vault in Jerusalem holds a piece of paper that scholars have dated for over 70 years. It's a fragment of the book of Daniel. Textbooks cite it. Professors teach it. Museum placards state its age like a fact carved in stone. Nobody questioned the date. Not seriously, not for decades. Then a research team fed a photo of it into an AI model. The model didn't read the words, it read the ink. It looked at strokes too small for any human eye to track, curves thinner than a hair, angles no ruler could measure. And it pushed the fragment's age back by 65 years. That's not a small correction. That's a machine finding something thousands of scholars missed for 7 decades, working with the same physical object, under the same bright lab lights with the same trained eyes. This isn't a movie plot, and it isn't a reenactment stitched together for a documentary. It happened this year. It was published in a real peer-reviewed science journal, and it's already forcing historians to ask an uncomfortable question. How much of what we think we know about the ancient world was actually proven, and how much was just a very good guess repeated so many times it started to sound like fact? By the end of this video, you'll know exactly what the machine found, how it found it, and why one single manuscript has scholars quietly rethinking a timeline they've trusted for most of their careers. To understand why any of this matters, you first need to understand what the Dead Sea Scrolls actually are, and why dating them has been such a stubborn, decades-long headache. The scrolls were found between 1946 and 1956 in a cluster of caves near the ruins of a place called Qumran, right along the edge of the Dead Sea, in what is today the West Bank. They are the oldest known manuscripts of the Hebrew Bible ever recovered, along with a huge range of other religious texts, legal documents, and community writings from the same general period. Before these caves were opened, the oldest complete Hebrew Bible manuscripts scholars had access to dated to around the 10th century of the Common Era. Picture a family owning a single handwritten letter from the year 1000 and treating it as their oldest family record. Now imagine finding a second letter from the same family, over 1,000 years older than that. That's roughly the size of the leap the Dead Sea Scrolls represented the moment they were found. In one single discovery, the window into the ancient Hebrew Bible was pushed back by more than 1,000 years. It instantly became one of the single most important archaeological finds of the entire 20th century for understanding the actual textual roots of Judaism, and by extension, early Christianity. The story of how the scrolls were even found is worth pausing on because it says something about how much of this entire field has always mixed pure chance with painstaking, grinding, scholarly work. The very first scrolls were reportedly found by Bedouin shepherds, searching for a lost goat near the cliffs of Qumran, sometime in 1946 or 1947. According to the traditional account, one of them tossed a rock into a dark opening in the rock face, expecting to hear the goat. Instead, he heard the sound of something breaking. Inside that cave were ancient clay jars, and inside those jars were leather and papyrus manuscripts that had survived, largely intact, in the region's uniquely dry desert conditions for roughly 2,000 years. Word of the find slowly made its way to antiquities dealers and eventually to scholars, who realized almost immediately that they were looking at something extraordinary. That discovery triggered a series of far more systematic excavations across 11 separate caves in the surrounding cliffs throughout the 1950s. Together, those digs yielded tens of thousands of individual fragments, representing somewhere between 900 and 1,000 distinct original manuscripts. Piecing those fragments back together into coherent, readable texts became one of the largest and most demanding puzzles in the history of archaeology. Some fragments took decades to match, based on nothing more than the shape of a torn edge or the particular slant of a single scribe's handwriting. In a very real sense, scholars are still working on that puzzle today, matching new pieces, revising old translations, and occasionally discovering that 2 fragments long, assumed to belong to different scrolls, actually came from the very same sheet. Traditionally, dating any specific scroll relied almost entirely on a method called paleography. That's a fairly academic-sounding word, but the idea behind it is simple. Paleography is basically the study of ancient handwriting. Trained specialists compare the shape, the slant, and the individual stroke patterns of letters on an undated manuscript against a small set of other manuscripts whose dates are already known through separate evidence. It is a genuinely skilled scholarly discipline built on decades of accumulated expertise, apprenticeship, and careful comparison. But it is also, by its very nature, subjective. It depends heavily on the trained eye and personal judgment of individual experts, and it has always been working with a real, frustrating gap in the underlying evidence. There are very few Hebrew or Aramaic manuscripts firmly dated to the 5th and 4th centuries before the Common Era. There's then a separate, better documented cluster of material from the 1st and 2nd centuries of the Common Era. That left more than 1,000 individual scrolls from Qumran sitting in a kind of scholarly limbo, dated mostly through comparison and informed estimation rather than direct physical evidence, with real, sometimes significant disagreement between different paleography experts about exactly where a given fragment belonged on the timeline. Radiocarbon dating, the more familiar scientific method most people associate with dating ancient organic material, does exist as an alternative. It has been used on a limited number of the scrolls over the decades, but it comes with two serious practical limitations that have kept it from ever being applied broadly across the full collection. First, it's expensive. Running the test properly, with reliable results, costs real money, and museums and universities don't have unlimited budgets for testing thousands of individual fragments. Second, and more importantly, it's at least mildly destructive. It requires a small physical sample to be removed from the manuscript and consumed entirely during the testing process. For a fragile, irreplaceable body of ancient manuscripts, where every single fragment is treated as a precious, finite archaeological resource, that's a serious concern. Curators and antiquities authorities are understandably cautious about authorizing any procedure that permanently destroys even a tiny piece of an original document that has already survived 2,000 years. Because of that caution, only a small fraction of the roughly 1,000 scroll fragments recovered from the Qumran caves have ever actually been radiocarbon dated directly. Everything else has relied on paleographic estimation. Educated guesswork, built on real expertise, but guesswork nonetheless. This is the exact problem a research team led by Mladen Popovic, head of the Qumran Institute at the University of Groningen in the Netherlands, set out to solve. And the solution they built is the reason this entire story is worth telling. Rather than treating radiocarbon dating and paleography as two separate competing methods, forced to work in isolation from one another, the team built an artificial intelligence model designed to learn from both at the same time. The goal was to extract far more precise information from a scroll's handwriting than any human paleographer could reliably track by eye alone, no matter how experienced or well-trained they were. They named the model Enoch, after a Jewish scribal figure from the Book of Genesis, described there as the great-grandfather of Noah. The name is also a nod to a separate ancient text called the Book of Enoch, itself found among the Dead Sea Scrolls collection. It's a fitting name for a tool built specifically to read the handwriting of ancient scribes, most of whom have been dead for over 2,000 years, and none of whom left behind so much as a signature to confirm exactly when they were writing. Enoch's foundation was built using a previously developed deep neural network called Binet. That's the underlying engine, the piece of software architecture Enoch was built on top of. Binet was originally designed to detect and map the microscopic ink trace patterns left behind on handwritten documents. That means the tiny variations in curvature, pressure, and stroke direction within individual letters, the kind of subtle physical fingerprint that stays consistent for a given scribe or scribal tradition, but is far too subtle and far too numerous for a human researcher to consistently measure and compare across hundreds of manuscripts. It's worth slowing down here and actually understanding how a system like this works, because it explains why it can pick up on things human paleographers, however skilled, simply cannot. Every single time a scribe forms a letter, tiny, largely unconscious habits in hand movement, pen angle, and pressure leave behind a kind of physical signature in the ink trace itself. The precise curvature of one particular stroke, the exact angle at which two lines meet, the subtle geometric relationship between one letter and the next letter beside it. A trained human paleographer can absolutely recognize broad differences in handwriting style between different eras and different scribal schools. That's real, hard-earned expertise, and nothing about this study is trying to dismiss it. What a neural network like Binet can do, that a human genuinely cannot, is measure hundreds of these tiny geometric features simultaneously across every single character in a manuscript, and then statistically compare that entire numerical fingerprint against a large reference set of other manuscripts with known ages. It can do this at a level of precision and consistency no human eye could sustain across thousands of individual letters, hour after hour, without fatigue, without bias, without a bad night's sleep changing the outcome. The team started by selecting 24 scroll samples, specifically chosen to represent a genuinely diverse range of manuscripts, different scribes, different scripts, different suspected time periods. They had those 24 samples radiocarbon dated directly, working in careful collaboration with the Israel Antiquities Authority, the government body responsible for preserving and overseeing these artifacts. High-resolution digital images of the ink trace patterns from those 24 newly dated samples then became the training data Enoch learned from. That allowed the model to build a genuinely quantified statistical relationship between specific handwriting style features and confirmed radiocarbon-based ages, rather than relying purely on the comparative intuition that traditional paleography has always depended on. Once the model was trained, it needed to prove it actually worked before anyone could trust a single one of its conclusions. And to their credit, the team built that verification directly into the study rather than skipping straight to the exciting part. They tested Enoch against manuscripts where the dating information had been deliberately withheld from the model during training, and then checked its predictions against the real, already known answers. This is a basic but essential scientific safeguard. If you want to know whether a tool can predict something it hasn't seen before, you hide the answer, let it guess, and then check the guess. Enoch came back accurate 85% of the time in that held-back validation test, with a typical margin of error of roughly 28 to 31 years. That's a genuinely tight window for dating handwriting on material that is, in some cases, over 2,000 years old. Only after that validation step did the researchers turn Enoch loose on the real target of the study. 135 previously undated Dead Sea Scroll fragments. These were manuscripts that had never been directly radiocarbon dated and had only ever carried a paleographic estimate, in some cases disputed, and in most cases simply treated as reasonably settled by convention rather than backed by hard physical evidence. The results were published on June 4th of this year in the peer-reviewed journal PLOS One, and in the researchers' own words, they were striking. Enoch's predictions aligned with traditional paleographic estimates in the large majority of cases, roughly 79%, which on its own is a meaningful validation of decades of careful paleographic scholarship carried out by real human experts. But in the remaining cases, where Enoch's assessment genuinely diverged from the accepted paleographic dating, the pattern was consistent and frankly surprising. Nearly every one of those disagreements pushed the manuscript's estimated age older, not younger, in some cases by as much as 50 to 150 years. The AI model wasn't finding evidence that scholars had been overestimating the scroll's antiquity. It was consistently finding evidence they'd been underestimating it. That directionality is worth sitting with for a second, because if a model's errors were essentially random, you'd expect corrections to scatter roughly evenly in both directions. Some manuscripts pushed older, some pushed younger, the mistakes canceling each other out over a large enough sample. A consistent, one-directional pattern across dozens of separate manuscripts is a much stronger signal that something systematic had been quietly built into the traditional paleographic timeline all along, rather than simple noise or random model error. The single most significant individual result to come out of this entire study involves the Book of Daniel. Specifically, a fragment cataloged as 4Q1014, which preserves 3 chapters of that biblical book. Paleographers had traditionally placed the creation of this specific manuscript at around 165 BCE. That date carries real historical weight because it sits right around the time scholars believe the final chapters of the Book of Daniel were actually composed, tied closely to real historical events during the Maccabean revolt against Seleucid rule over Judea. That connection matters a great deal to biblical scholars because the Book of Daniel is widely understood among historians studying it critically rather than purely theologically, as a text whose later chapters were likely written to speak directly to the political and religious crisis of that specific moment, using the frame of an earlier legendary figure to comment on contemporary persecution. A manuscript dated right around 165 BCE would represent something close to a copy made very shortly after the text itself was likely finished, which is exactly why the traditional dating has carried so much interpretive weight for so long. It made this specific fragment feel like a first edition, a nearly first-hand record of a text still fresh off the scribe's desk. Enoch's analysis, incorporating both the handwriting style data and the radiocarbon evidence, placed the same fragment significantly earlier, in a range extending back toward roughly 230 BCE. That's not a minor adjustment. It means this particular physical copy of the text may have been produced considerably closer to, or in some interpretations, potentially even somewhat earlier than, the specific events the book's later chapters are describing. That's a detail with real, ongoing significance for scholars studying exactly how and when this specific biblical book took the form it has today, and how quickly a text like this might have been copied and circulated after it was first composed. If the copy is older than the crisis it supposedly reflects, that reshapes some very old assumptions about how and when the book actually came together. A separate manuscript, catalogued as 4Q19, containing text from the book of Ecclesiastes, was likewise redated meaningfully older than the previous paleographic consensus had placed it. Beyond individual manuscripts, Enoch's analysis also complicated something paleographers had long treated as a relatively clean, orderly transition, the shift between what's classified as Hasmonean-era script and the later Herodian-era script style, named for the two successive ruling dynasties over Judea during the relevant centuries. Paleographers have traditionally treated this stylistic shift as a fairly reliable chronological marker, precisely because it was assumed to track closely with the political transition between the two dynasties, giving scholars a useful, semi-independent way to roughly date other manuscripts whose handwriting style could be classified as belonging to one period or the other. According to the study's findings, that stylistic transition turns out to be considerably messier than the traditional paleographic timeline assumed, with genuine examples of what would conventionally be classified as Herodian-style handwriting appearing on manuscripts that Enoch's combined analysis dates to as much as 50 years before King Herod's own reign even began. That detail matters beyond just this one study, because paleographers have long used the Hasmonean to Herodian script transition as a kind of reference marker for roughly dating other undated manuscripts across the wider collection. If that marker is less precise or less strictly chronological than previously assumed, it has ripple effects for how confidently scholars can date manuscripts across the entire Qumran collection using handwriting style alone, since a marker many other date estimates have quietly leaned on turns out to be softer and less strictly sequential than the field had generally assumed. Stick with me here because this next part is the detail almost nobody outside this study has actually talked about in public. It's genuinely important at this point in the story to be precise about what this research does and does not actually claim, because the honest version of this discovery is more interesting than an exaggerated one, and it's also simply the accurate one. This is not a story about artificial intelligence overturning or discrediting the entire field of biblical scholarship. Popovich himself, in comments made not following the study's publication, was direct on exactly this point, stating plainly that AI still needs human beings, particularly in its own development and interpretation. Enoch didn't replace paleography. It was built by feeding it decades of real paleographic knowledge combined with hard radiocarbon evidence, and its results were checked against expert paleographic judgment at every stage, not treated as an independent oracle whose conclusions require no human verification at all. In the majority of cases tested, roughly 4 out of every 5, Enoch actually confirmed what traditional scholarship had already concluded, which is itself a genuinely significant vindication of decades of careful, old-fashioned paleographic work carried out entirely by human specialists, using nothing more than trained eyes and comparative judgment. Outside experts examining the study, including paleographer Christopher Rolston of George Washington University, engaged with the specific findings on their merits, rather than treating the AI's conclusions as automatically authoritative. That's exactly the kind of scholarly scrutiny a study with this much potential impact should reasonably expect, and frankly deserves. What makes this discovery genuinely significant, then, isn't that a machine proved human experts wrong. It's that it gave a field that has always been forced to rely heavily on trained, subjective judgment, a new complementary quantified tool, one explicitly designed to catch subtle handwriting details that consistently fall below the threshold of what a human eye, however well trained, can reliably track and compare across hundreds of separate manuscripts. As the researchers themselves put it in the published paper, the real advantage of the Enoch model is that it introduces a form of quantified objectivity into paleography, reducing the field's reliance on tacit, hard-to-verify expert intuition, by instead offering dating predictions as clearly stated, probability-based options, grounded simultaneously in physical radiocarbon evidence, and precise geometric measurement of the handwriting itself. That word, objectivity, is doing real work here, and it's worth being precise about what it does and doesn't mean. It doesn't mean the model is infallible or that its predictions should simply be accepted without further scrutiny. The researchers themselves built extensive validation testing specifically because they understood that claim would need real evidence behind it, not just a confident press release. What it means is that, for the first time, historians studying this specific collection have a dating method that produces the same result every time it's run on the same evidence, rather than one that can shift depending on which individual expert happens to be doing the comparing. And that consistency alone represents a genuine methodological upgrade for a field that has spent 70 years working without it. Because the model works from high-resolution digital images, rather than requiring a physical sample to be destroyed in testing, it offers something radiocarbon dating alone never could at this kind of scale: the ability to responsibly generate meaningful new date estimates across a much larger share of an irreplaceable manuscript collection without physically damaging a single additional fragment in the process. Consider what that combination actually unlocks going forward, because the implications extend well past this specific batch of 135 scrolls. There are still hundreds of additional Dead Sea Scroll fragments in existence that have never been directly radiocarbon dated at all, and realistically, Given the destructive and expensive nature of that testing method, many of them likely never will be through that method alone. A validated, quantified AI dating tool like Enoch offers a genuinely responsible path toward extending reliable date estimates across that much larger body of material without requiring a single additional physical sample to be consumed. And the researchers have been explicit that the underlying method isn't limited to the Dead Sea Scrolls specifically. The same basic approach, combining a smaller set of confirmed radiocarbon-dated reference samples with AI-driven handwriting style analysis, could reasonably be applied to other partially dated historical manuscript collections from entirely different eras and cultures, anywhere researchers face the same fundamental problem: a body of undated handwritten material sitting alongside a smaller, confirmed reference set that a properly trained model could learn from. The broader applicability is worth dwelling on for a moment, because it reframes this story from a single narrow archaeological result into something closer to a genuine methodological breakthrough for historical research as a whole. Museums, archives, and universities around the world hold enormous collections of undated or loosely dated handwritten historical documents, ranging from medieval European manuscripts to early Islamic texts to historical documents from societies across Asia and the Americas, where the same basic tension exists. A handful of firmly dated reference samples, and a much larger body of material dated mostly through comparative expert judgment rather than direct physical testing. A properly validated, field-specific version of the same Enoch approach, retrained on the relevant reference samples and handwriting traditions for any of those collections, could in principle offer the same kind of quantified, non-destructive dating precision this study just demonstrated for the Dead Sea Scrolls. That's speculative in the sense that no one has yet built and published results for those other applications. But it's grounded speculation, directly extending a method that has now been rigorously tested and shown to work on one of the most historically scrutinized manuscript collections on Earth. That explains what this tool can do going forward. But here's what it still can't do, and probably never will. It can't tell us what the scribes were thinking as they copied these words. It can't recover a name, a face, or a single spoken sentence from the person who actually held the pen. It only measures the physical trace they left behind, the mechanical habit of a hand moving across a surface 2,000 years ago. In some ways, that limitation is the whole point. This is a study about narrowing uncertainty, not eliminating mystery. The scribes themselves remain as anonymous as they always were. Only the paper they touched has started very quietly to talk. Step back now and consider the full shape of what actually happened here, because it holds together as a genuinely significant scientific story without needing a single exaggerated claim layered on top of it. A collection of ancient manuscripts, already recognized for over 70 years as one of the most important archaeological discoveries in the history of biblical scholarship, has spent most of that time carrying date estimates built primarily on trained expert intuition, rather than hard physical evidence, simply because no better method existed at any meaningful scale. A newly built, rigorously validated AI tool then went back over a meaningful slice of that same collection and found it was, in a consistent and directional way, genuinely older than the field's own working consensus had assumed for decades, including at least one manuscript containing a text tied directly to real, dated historical events in the ancient Near East. Every individual piece of this holds up under scrutiny. The historical gap in dated reference manuscripts explains why paleography alone was never going to be sufficient on its own. The cost and destructiveness of radiocarbon testing explains why it was never applied broadly across the full collection. The rigorous validation process, testing Enoch against known answers before trusting its predictions on unknown ones, explains why this result carries real scientific weight rather than reading as a speculative headline dressed up for clicks. Taken together, it amounts to something genuinely rare in the study of ancient history. A case where a brand new technological method, built specifically to correct for the acknowledged limitations of an older one, didn't simply confirm what experts already believed and quietly validate the status quo. It found real, measurable evidence that a meaningful portion of one of the most studied manuscript collections on Earth is older than virtually everyone studying it for the past 7 decades had assumed. And it did so by seeing something in the handwriting itself that no human eye, however expertly trained, had ever been able to reliably measure. It's worth sitting finally with what this actually changes and what it doesn't, because that distinction is where the real weight of this story sits. It doesn't rewrite the content of the Hebrew Bible, and it doesn't overturn the core religious or historical understanding of what these texts say. What it changes is something quieter and, in its own way, more foundational. It's the confidence with which historians can place a specific physical object in time, and by extension, how quickly certain ideas, certain texts, certain theological developments were actually being copied, circulated, and read by real people in the ancient world. A biblical book copied even 50 or 60 years earlier isn't just a number moving on a chart. It's a shift in how soon after composition an idea was already being physically reproduced and shared, which quietly reshapes questions scholars have debated for generations about how these traditions actually spread and solidified across ancient Judea and beyond. Popovich's own description of the tool as a kind of time machine isn't just a catchy line for a press release. It reflects something genuinely true about what quantified, AI-assisted paleography now makes possible. A more precise window into exactly when the hands that wrote the Bible were actually holding the pen. Not a perfect window, not a final answer, but a sharper one than the field has ever had before, built not on replacing human judgment, but on finally giving it something solid to stand on. If this made you think differently about how much of ancient history rests on educated estimation rather than hard, verifiable evidence, that's exactly the kind of thing this channel exists to dig into. If a machine can quietly correct 70 years of expert assumptions about the Dead Sea Scrolls, that tells you something about every other settled date in ancient history too. Subscribe, because every week we look at the moments modern science is quietly rewriting the timeline of the ancient world, and the Dead Sea Scrolls, even after 70 years of study, apparently still had more to reveal.